Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to start to use the law of sines to solve triangles. Up to this moment, you should have watched both of my videos on the law of sines, one being about the theorem and the proof of the law of sines, and the second one being a conceptual investigation of the ambiguous case for the law of sines. We have yet to actually go through a full example. So this will be our first full example, and it's a template for how to attack all law of sines and law of cosines problems. So the first thing I do when somebody hands me information about a triangle, and it could be, by the way, a real world problem. Just somebody says the angle between these things is something, this distance is whatever. Rather than drawing things out, I build a table. So the initial thing I'm going to do here is not draw, but instead to fill out a table. The first column of my table will be angles. So angle A, angle B, and angle C. And the second column will be the sides, side A, side B, side C. And I'll fill in what they've handed me. So they handed me that side C is 115 in length. I don't know what the units are, and it doesn't really matter to me. Angle C was 100 degrees, and angle B is 29 degrees. Now remember, the law of sines allows us to relate sides to angles using B over sine of B is equal to C over sine of C. I'll write that down in a moment. But let me just say, if you're in a class where your instructor requires you to draw out the triangle, first you would start by drawing a horizontal side. That's just a good piece of advice here. Take the largest of the angles that you were handed. And by the way, you'll, with law of sines, always be handed at least one angle. And so I'll take this largest angle here and I'll open up 100 degree angle. That's just kind of eyeballing it right there. So that'll be my angle C. They gave me a side C. That's the side opposite that angle. So side C is actually 115. And then the tallest, or the highest vertex is the other angle they've handed me. If they hand me another angle, I just plot that up above as the highest vertex. So that's angle B, which is 29 degrees. If on the other hand, they didn't hand me another angle, but instead they handed me a side, I would label that as the side they handed me. Okay, so it's just kind of important to note here. But otherwise, drawing the triangle for me is really not worth it. And I already had this drawn, so I'm going to bring back my old triangle drawing. There we go. Now, let's go ahead and see how the law of sines works finally, right? So, law of sines, you'll know you're going to use it if you have in your table a full row. A completed row means you're using the law of sines. So I'm going to go ahead and say the law of sines, I can use that completed row to find this missing piece of information. If I have a semi-complete row, I will use my completed row to find the missing information in that semi-complete row. So I could say side B, that unknown side, is to the sine of its opposite angle, as side C, which is 115, is to the sine of its opposite angle, which is 100. Again, that's using the law of sines. The law of sines, which is this formula right here, can be used as written, or you could take its reciprocals and set them equal to each other, which is commonly what I end up doing anyway. But all you need to do is memorize only one version of this. You have both at that moment. And in some textbooks, they actually write out all the versions, but all you really need is to remember that sine of an angle to its opposite side is the same as the sine of a different angle is to its opposite side. It doesn't matter what the angles and sides are as long as you match these up and these up. All right. So notice in this case, I can just easily solve for b by multiplying both sides by the sine of 29 degrees. So I get 115 sine of 29 degrees over sine of 100 degrees. That's what side B is. And I'll grab a calculator to compute that, but I don't really need to compute it right now because I can find something else very quickly in the meantime. So note, we have side B. I just haven't computed it with a calculator yet. I'll show you how to do that in a moment. Angle A is going to be very easy to find because we have two angles within this triangle. And remember, the interior angles of a triangle must add to 180 degrees. So if 100 of those degrees is taken by C and 29 are taken by B, then 51 degrees are left for angle A. And note, I use blue ink to showcase what I've calculated. There we go. And now you can see I can use this completed row to help me fill out the rest of that uncompleted row there. Once I have a semi-completed row and a completed row, I can use both of them in concert to complete that last piece of information. So doing that, I could say A is to the sine of its opposite angle, which is 51 degrees, as C, which is 115, is to its opposite angle, sine of its opposite angle, which is 100 degrees. And that will imply that side A is equal to 115 sine of 51 degrees divided by sine of 100 degrees. Notice these two formulas are very close to one another, right? They're very similar looking. And that's what you're going to notice when you work with a lot of law of sines problems. Now, to showcase how to compute these values using a calculator, you want to make sure you're in radian mode, degree mode, specifically for applications, because applications often are done with degrees. And here I am in Desmos, and I'm just going to make sure I'm in degree mode. It's in degree mode if that's already lit up and it says degree, so I know I'm in degree mode. And now my numbers were 115 sine of 29 degrees. You don't need the degree sign, it already knows you're in degrees, divided by sine of 100. It's good to do it all at once rather than rounding each step. You don't want to round and then round and then round. Just type it all out at once. It should look like what your handwriting looks like as far as form, 115 sine of 29 over sine of 100 degrees. And so this tells us that B is roughly, and I'm just going to round to a single decimal place, 56.6. I'm actually writing that in the background so I don't have to memorize it. And then side A was given as, and I'll just do it this way, 115 sine of 51. So let me write in here of 51, and that was divided by sine of 100. And this is 90.8 degrees. So I'll write that down on my end, and then I'll hop back over there. 90.8, whoops, not degrees, 90.8. That's the length, not degrees. And there you have it. We filled out the entire table. And so now we know all the information we need to know about this. So the side opposite angle B is roughly 56.6 in length. The side opposite angle A, that's angle A right there, is roughly 90.8 in length. And by the way, angle A itself was 51 degrees. So there you go. We've filled out the triangle. Now notice I didn't even bother. The triangle is very minor to me. What's important is the table itself, because that really informs how I'm going to go ahead and do this. And I didn't use blue ink as I said I was going to, and I apologize. It's 90.8 and 56.6. Sometimes I just kind of move along without thinking. So there you go. All right, so let's go ahead and try yet another problem. When you're learning the law of sines, it's best to do as many problems as possible. So here's another sketch and solve. And again, I don't start by sketching. In fact, I rarely even do any sketching here, but I'll just draw out the table angle A, angle B, angle C, and then side A, side B, and side C. And they tell me angle B is 13.4 degrees. They tell me that angle C is 24.8 degrees. And they tell me that side C is 315 in length. By the way, if you have taken trig before and you know there's like angle, side, angle, 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 side, side, angle, angle, whatever it is, right? Those are memorizable patterns, but actually I don't think they're worthwhile. I just look at this and go, oh, look, we've got a full complete row. So I can use that full complete row to build out the rest of that row. Also, I can find this missing angle because there's 180 degrees in the interior angles of a triangle. So that allows me to, again, use this full complete row to complete that row. So I'm going to go ahead and draw out my triangle, even though normally I wouldn't. But I'm going to go ahead and label this angle C. And remember, I do that because it's the largest angle that I've been given. So I'll go ahead and do that right now. And I've drawn that in. That's roughly 24.8 degrees right there. And now I'm going to go ahead and mark a point right here. And I'm going to hang angle B from there. And angle B was 13.4 degrees. So I'm just going to have a 13.4 degree angle. Now you can see I sketched out a 13.4 degree angle for angle B here. It's really small. So 13.4 degrees. Let's use a double hash there. Very, very small. And note that I didn't need my horizontal length here to be this long. So I'm just going to erase off what I didn't need. And finally, they told me this side C is equal to whatever it was, 315. This picture does not help me. So that's why I don't draw it. It doesn't really super help me in these problems. I will zoom in so you can see the picture, but that's not really going to help you either. So let's go ahead and find the missing information. I can at least find this missing angle here. I'll use blue ink for that. So I'm going to grab a calculator rather than going over to Desmos, because then that means I have to pause my screen. And I get 141.8 degrees. By the way, that does kind of help in the picture just because this angle right here is angle A, and that definitely is an obtuse angle. So it does match our logic. Now let's go over and find those missing sides using the law of sines. I will use this full row to help me complete that row. So again, side B is to the sine of angle B, as side C is to the sine of its opposite angle, which is 24, sine of 24.8 degrees. And I'll go ahead and compute that out. Actually, I'm going to wait to write it down until the very end. Actually, I could compute it right now. I'll just do it with my calculator so you don't have to see me go to Desmos again. And that roughly comes out to 174.0. It's actually 0.03, but rounded to the nearest decimal place, it's 0.0. It should make sense that it's going to be smaller in length than side C because side C is opposite a larger angle. So that's a good logic check. Also, make sure you're in degree mode when you do these problems. Now I'm going to use, again, this highlighted complete row because these are exact values. It's better to use exact values to compute your answers than it is to use approximate values. So let's see, side A is to the sine of its opposite angle, sine of 141.8 degrees, as side C is to the sine of its opposite angle. Now in this case, it should be fairly obvious that side A is going to be the longest side by far. Side A will equal 315 sine of 141.8 degrees all over sine of 24.8 degrees. It's because it's opposite the largest angle, so it's got to be the longest side. And that gets me approximately 464.4. There we go. There's no ambiguity, by the way. I haven't even started the ambiguous case yet. And that's because, well, there was no need for it. We haven't had a need for the ambiguous case yet. I'll let you know when we reach the ambiguous case. We have reached the ambiguous case. See, I told you I'd let you know. So solve the triangle, or sketch and solve, right? Even if I don't know it's the ambiguous case, I still just draw out a table. Angle A, we don't know that. Angle B, we don't know that. Angle C, we do know. That's 68 degrees. Side A, we don't know that. Side B, that's length 12. And side C, that is also of length 12. Perfect. So we now can see that we have a completed row, and we can use that completed row to find other missing values in this triangle. Specifically, I can use this completed row to help me find that missing angle B. And once I find that missing angle B, I can then fill in that angle A, which means I can use this completed row to fill in that side A. It's like a set of dominoes. Start knocking them over. But as I just mentioned, this is the ambiguous case. So let's go ahead and see why it's the ambiguous case. We'll start with just doing what we would normally do. So I don't want to invent an idea that things change in this world, or that, I'm going to do one method for one thing and another method for another thing. No, it's the same method all the time. It's the same formula, in fact, with the exception that I don't write it as A over sine of A equals B over sine of B. Instead, because my missing piece of information is an angle, I will just flip that formula. So I'll say the sine of angle B is to its side, 12, as the sine of angle C, which is 68 degrees, is to its side, 12. Now, I know because those two side lengths are the same, it's going to be 68 degrees. I totally get it, okay? But I'm just showing you how you would solve this if those weren't the same. All right, so solving for angle B. Well, you would multiply both sides by 12, and you get the sine of B is equal to the sine of 68 degrees. And you look at that and you say, well, therefore B is 68 degrees. And it is actually true. B would be 68 degrees. But how would you actually find that? Normally, you would take the arc sine of both sides. Now, I give a big talk on why the inverse trig functions are a bit sketchy to deal with. When you're dealing with law of sines and law of cosines, which we're dealing with law of sines right now, when you're dealing with the law of sines or the law of cosines, you're solving for real angles, not negative angles, but positive angles. And so when you use an inverse trig function like we're going to use here, so the angle B is equal to sine inverse of the sine of 68 degrees. When you do that, just note that the arc sine or the sine inverse only returns angles that are acute. In other words, it returns angles less than 90 degrees and greater than 0 degrees. Technically, it goes from negative 90 to net 90 degrees, but in these law of sines problems and law of cosines problems, it will always be a positive angle. So always consider that the sine inverse that you're going to be using here is going to return an angle between 0 and 90 degrees. That's so important that I'm going to write it off to the side here. So with law of sines problems, and that's what LOS means, law of sines problems, the arc sine, which is what you're going to use when you're doing law of sines, returns acute positive angles. That is, the sine inverse will be an angle between 0 degrees and 90 degrees. That's going to be a big issue in the long run, because what if the angle for side B here, opposite side B, what if that angle was greater than 90 degrees? It's not, because side length B is the same as this side length C, but what if side length B was huge, like 100 or some silliness like that? Then the angle B must be greater than 90 degrees. But there's no way doing this process right here, there's no way that your sine inverse would ever give you that angle. And that's the ambiguity of the law of sines. So what we're going to do is we're going to grab a calculator, even though you don't need to grab a calculator for this specific one. We know that it's going to be 68 degrees, but I'm just going to showcase how you'd grab a calculator. So we're going to grab a calculator and compute this angle. Sorry about that. The fan on my computer started going crazy. And then after computing this angle, we're going to ask ourselves a secondary question. So here we are in Desmos. What is the arc sine of the sine of 68 degrees? There you go. It's 68 degrees. So once I have that, I just go over and I fill it in my table. I say, okay, well, this is 68 degrees. Now, before I continue any further, I'm just going to ask myself, is there room for the supplement of that angle? Now, you might be wondering why I'm asking that question. The first thing I'm going to do is just ask the question. Let's just ask ourselves, could we have instead put the supplement of 68 degrees there? And then I'll tell you why I'm asking that question. So let me go ahead and write that over here. I'll do it right here. So when using the law of sines to find an angle, which is exactly what we're doing here, we're using the law of sines. We found that angle of 68 degrees there, but we had to use the law of sines to do it. So when using the law of sines to find an angle, you need to check whether the supplement of that angle could have fit. If so, you have two triangles. So let's see what I mean by would the supplement have fit. The supplement I just do as B bar. So I say let B bar equal the supplement of that 68 degree angle. That is, it's 180 minus 68 degrees. Well, 180 minus 68 degrees is 112 degrees. Okay, the question is, could we have built a second triangle with 112 there instead of 68? And the answer is absolutely not. But why? It's because if you were allowed to have that angle be 112 degrees, well, we already were given a concrete angle for C. The concrete angle for C was 68 degrees. Maybe I should just keep it as C, which means angle A in this alternate universe, angle A would be, let's see, 180 minus 112 minus 68. Angle A would be 0 degrees. Well, that's not even a triangle. So there's no other triangle. So again, when using the law of sines to find an angle, which we just did, you need to check whether the supplement of that angle could have fit. So the first angle we found will fit, period. That's okay. But the second angle we find, the supplement, is a big question mark. Would that have fit? Well, let's find out. And you just do the computations. What would it force the unknown angle A to be in that situation? It would force it to be 0 degrees. So there's not a second triangle. So I'm going to write that down here. Let B equal this. That would imply that A bar, the other universe's angle A, would be 0 degrees, which implies no triangle, no second triangle. Okay. So that is how you work with the ambiguous case. The reason why we're working with the supplement, this is more for a visual, going back to our conceptual investigation of the law of sines, the ambiguous case, that's this case right here. If you have two triangles, well, the first triangle you find is this, or the first angle you find is that angle right there. That would be angle B, right? And if you notice, sure does look like that measure right there is the same exact angle. And in fact, it is. If you can imagine a big bar right here in blue coming down and it strikes right here, well, when it swings and comes back up, it'll strike at the equal and opposite side. So these two angles are actually the same angle. However, the second triangle that we get is this green triangle. So this angle right here is actually B bar. And notice if this angle is B and this angle is B bar, B bar is the supplement of B. In other words, B bar plus B add to 180 degrees. And that's why the B bar, the alternative universe triangle, is always the supplement of the angle B that we originally find. If there are two triangles, angle B will be the supplement and it will fit a second triangle. In this case, it didn't, but I'm just saying if it could, it would. Well, that's good news. There's not a second triangle here because that just means we're pretty much almost done. We just need to fill out what this missing angle is. Well, we know we have 180 degrees to spend in a triangle, and we just spent, what is that, 120, 136 of them, 136 degrees of them. So we must only have 44 degrees left for that angle. Now that we know that angle is 44 degrees, we can find that missing side by using, again, that solid filled out row to help us find that missing side A using the law of sines. So the law of sines tells us that missing side A is to its angle, the sine of its angle, 44 degrees, as the concrete side 12 is to the sine of its angle, 68 degrees. Solving for A, we get A is equal to 12 sine of 44 degrees divided by sine of 68 degrees. And then I'll grab a calculator and compute this out very quickly. And rounded to the nearest tenth, it's 9.0. So this is approximately 9.0 in length. And that should make sense. It's opposite a smaller angle, so it should be a smaller side length. Now that is our first dabbling into law of sines with the ambiguous case. Let's do another one. Here we are, sketch a triangle and solve it. Same instructions throughout, right? So let's go ahead and make our table. Let's see, angle A was given to us to be 125 degrees. Angle B was not handed to us, and angle C was not handed to us. So this is likely to be an ambiguous case just because we're missing two angles. You start getting used to that idea. Side A was 20, or is 20, I guess. Side B is unknown, and side C is 45. All right, so I'm going to go ahead and highlight the fact that we've been given a beautiful, full, complete row. That tells me law of sines. I'm going to use law of sines. And it's probably a good habit to start writing that there once you see a full complete row, because if you don't have a full complete row, it's going to be the other case, the law of cosines, which we have not seen yet. We are going to go ahead and use this given row to help us find that missing angle C. But again, my advice that I said before, when using the law of sines to find an angle, you need to check whether the supplement of that angle could have fit. If so, you have two triangles. So let's go ahead and find that angle. We know that the sine of that angle, I'll write this, all my work I'll write in blue here. So the sine of that angle C is to the side C as the sine of angle A, which is 125 degrees, is to the side A, which is 20. If you multiply both sides by 45, you will get sine of C is equal to 45 sine of 125 degrees divided by 20. And now I will go ahead and take the sine inverse of both sides so that I can find out what the acute angle C is. And the acute angle C, because remember when you use a sine inverse, it will only return acute angles. And so in this case, we're going to find the smaller of the two possibilities, if there are two possibilities. Or we might find out that there's no triangle. So sine inverse of 45 times the sine of 125 degrees over 20 is what angle C should be. So let me show you how to compute this, again, using Desmos. Here I am in Desmos. I'll just type in arc sine. And I should say we're finding angle C. So I'm just to say angle C is equal to arc sine of 45 sine of 125 divided by 20. And notice what happens. It tells us that this is undefined. What's nice about using technology, and that's what you're going to have to use when you're solving triangles using the law of sines or law of cosines, is that the law of sines will tell you immediately when you grab a calculator whether or not there's no triangles. That happens when you get this result. So either you'll get undefined or you'll get an error or something like that. You should double check to make sure all your computations, all your typing is correct. So we are doing the arc sine, which is a sine inverse. We did have 45. We did have the sine of 125 degrees. We are in degree mode here. I can see it just right here. We're in degree mode. And we're dividing that by 20. The reason why it is undefined is because that ratio, 45 times the sine of 125, sine of 125, divided by 20, and that was supposed to be a 45, by the way, is 1.8. And the sine will never return a value greater than 1. So that is why this arc sine of that number greater than 1 is undefined, because the arc sine cannot take a number as its argument greater than 1. There you go. So going back here, we just write down that it's undefined, which means there's no such triangle that satisfies that given information. So I could just say there's no triangle, no solution, no triangle, whatever you want to call it. So be aware that can happen, but luckily your calculator will tell you. That's the beautiful part of the law of sines with the ambiguous case where you won't get a triangle. Your calculator will tell you very quickly, right when you first start computing, in fact. It'll just tell you there's no possible angle for that. All right. And by the way, let me give you the visual of what we just did. It's the top case right here, where they gave us a side length so short that it couldn't create a triangle. That's basically what happened. So that's a visual of why we have no triangle. Let's tackle another one. In this case, again, build a table. So angle A was not given. Angle B was given. That's 25 degrees. Angle C was not given. So I know this is going to be the ambiguous case just because I know that, I don't know it until I fill out the other side. Let's go ahead and fill out the other side. Side A, we have not been given. Side B, we have been given. That is 25. And side C is 30. Now I can easily see that this is the ambiguous case because 1, I have a full row, which means I'm guaranteed to use the law of sines. But 2, I'm going to use that row to find a missing angle. And remember, when you're finding a missing angle using the law of sines, let me get that all the way over so I don't cover up my handwriting. When you're using the law of sines to find an angle, you could possibly have 2 triangles. You need to take the supplement of the angle you find, and if that works, if that would also fit in this triangle, then you have 2 triangles. So let's go ahead and see how this works. All right, do what we were doing before, and I'll just do it off to the side here in blue. So I know that angle C, the sine of angle C is to its opposite side of 30, just as the sine of angle B, which is 25 degrees, is to its opposite side, 25. Multiplying both sides by 30, I get that the sine of angle C is equal to 30 times sine of 25 degrees over 25. I also want to mention here before I continue that I'm a stickler for people simplifying numbers unless you're going to grab a calculator. In this case, I know I'm going to be grabbing a calculator, so I'm not simplifying these numbers. And that's pretty much a rule of thumb throughout mathematics. If you know you're going to grab a calculator, don't bother simplifying. You're just wasting your time. It only takes you a few extra moments to type in a couple extra digits there. So Anyway, this implies the angle C is going to be the sine inverse of 30 sine of 25 degrees divided by 25. This one I want to show in Desmos again. So I'll hop over there. And I'm going to use capital C here to equal the arc sine of, and it was 30 sine of 25 degrees divided by 25. And notice this does give us an answer of 30 roughly 0.5. Now notice also that I saved this as C here. The reason why I did that is so that I can use that in future computations. So I fill in that information, 30.5 degrees is what we just found. And the question is, before I go any further, would the supplement of that angle have fit? That is, I'm just going to go ahead and pause and write it here. Would 180 degrees minus 30.5 have also fit? And remember, or not remember, but quickly compute that that's 149.5 degrees. So the question is, would we been able to fit a 149.5 degree angle here instead? Well, 149.5 plus 25 actually does leave enough room for an extra angle A. Again, let me say that again. So 180 degrees, well, maybe I should say, if sides or angle B is equal to 25. Notice I wrote B bar because I'm going to write a second table and I'm going to use bars for everything. So if B bar was 25 degrees, which is what they handed us, and if instead of 30.5, we used 149.5, and C bar is equal to 149.5 degrees, then A bar, well, remember in the last problem, or the problem we did 2 problems ago, we had that A bar was 0. So there was no way we had any hope of having that angle fit. However, or to create a triangle out of that. However, in this case, if you take 180 minus 25 minus 149.5, you'll get that A bar is equal to 5.5 degrees. Yep, I can create a triangle, a second triangle. So this implies second triangle. Now, when I write that down, I just immediately go over to maybe the right-hand side of this, and I'll just write a second table. You could use the same color. It doesn't actually matter. I don't even know if you're even using colors, to be honest with you. But I'll write A bar here, and I'll write B bar and C bar, and then little side A bar and little side B bar, whoops, and little side C bar. All right in there. I fill in what they gave me, so the original information still holds. None of that changes. That's all solid. We also know, because we can compute it out, or we have computed it out, that C bar is approximately 149.5 degrees. And we have also computed A bar, so I might as well write that in there. It's 5.5 degrees. Again, approximately. Approximately 5.5 degrees. Notice I almost have this table filled out. And in fact, I'm going to finish filling out this other table as well, because that angle that's missing here is just 180 minus the sum of these two angles. But this is where good use of a calculator is important. The only thing we actually computed so far was that angle C. Now I'm going to go ahead and save as much of the information as possible as variables in Desmos. So we're back in Desmos right now. That is the angle C. Angle A of that first triangle would be 180 minus the angle B they handed us, which is 25, minus the angle C we computed. Notice that that angle A is more exact than had I just wrote 124.5. So I am going to still write roughly 124.5 in my notes, but just to let you know, I'm saving the value here so that it's better to compute with if I need to. It's not that I'm going to need to. I may or may not. Also, angle B bar, or C bar, sorry, angle C bar was supposed to be the supplement of angle C, that's right. I'm just looking around for everything on my piece of paper down here on my digital board. But yeah, angle C bar is supposed to be the supplement of angle C. Now, I really don't know how to write a C bar here, so I'm just going to write capital C, and I'm going to use the lowercase sub. That's like that's a shift minus sign, and I'll write bar, C bar, is equal to 180 minus C. So there's our supplement. And that was 149.5, which is exactly what we thought it would be. And then A bar, A sub B A R, of that second triangle was going to be 180 minus the 25-degree angle for angle B and minus C bar, C sub bar. And that's 5.5 degrees. But really what you're seeing here is a more exact measurement of that. It's 5.47364 blah, blah, blah degrees. So just in case we need that, I like to save that information. We're not going to need it here, but I'm just telling you, it's good to have just in case. And now that I think about it, we are going to use it. So let's go ahead and show why. So why did I say that we're going to need those saved values? Well, we now just have to find the missing sides of both of those two triangles. We have our smaller triangle with the 30.5 degree angle for C, and our larger triangle with the 149 degree angle for C. But the problem is, in either case, you're going to use the given information to help you find that missing side. So in both cases, you're just going to use this row to find that missing piece and this row to find that missing piece. But the problem is that in that computation, you're using an approximated value for your angles A. Let me showcase this with handwriting so you can see what I mean. So in that first triangle, side A is to the sine of that approximated angle, 124.5 degrees. So instead of writing that, I'm going to write side A is to sine of angle A, because I have that saved in Desmos as its non-approximated value. And that ratio is the same as side B, which is 25, is to sine of its angle 25 degrees. And so I know that side little a is going to be 25 sine of angle A over sine of 25 degrees. And then we would go to Desmos and use the A in Desmos to figure out what the capital A in Desmos to figure out what this value is. If you're taking a college level course, like a transfer level course in trigonometry, like you probably are, maybe pre-calculus, then you should know attention to detail is critical. You must wait on grabbing a calculator for your computations until the very end. All my calculator computations have been just to display approximated values, but actually when I compute, I am not going to compute with my approximations. So that's important for you to follow that advice. Using the law of sines on A bar, well, side A bar is to the sine of angle A bar, as side B bar, which is 25, is to sine of angle B bar, which is 25 degrees. And therefore, side A bar is 25 sine of angle A bar over sine of 25 degrees. The reason why I wrote both of these out before computing them is for you to notice they're actually the same exact computation, but with just different angles in that sign in the numerator. And so I'm going to take advantage of that. We are back here in Desmos, and I will just compute the 25 sine of A divided by sine of 25 degrees. And that will give me, that's our little a, by the way. Maybe I should have written little a there. That gives us side little a, and I'm going to write that in the background. And now that I've done that, I'm going to go ahead and find side little a bar. Side little a bar is the same computation that we had up there. It's 25 sine of capital A sub bar divided by sine of 25. There we go, which is 5.6 roughly. And so I just want you to notice that saving your values is incredibly important here. You just have to be able to do that because it really makes your computations a lot faster, and it keeps you from making weird approximation mistakes. And in the end, we have two filled out tables which represent the triangles, the two triangles for this situation. This is pretty much the end all be all for the law of sines problems. There is one more problem in this video, and that's if you're given a triangle, but I just wanted to make sure that everybody was on the same page with this, and that you realize whenever you're using law of sines to find an angle, you need to check whether the supplement of that angle could have fit. If so, you have two triangles. All right, let's go to the next example here. And like I said, this is the last example. I just wanted one example that had something already pre-written. So find the measure of that angle X. So this is pre-written. This is something that you would find in a textbook. In fact, this is from a textbook. And what you could do here is you could just label these anything you want. I'm going to label this side, or this angle A, this angle B, this angle up here, angle C. Therefore, this would be side little a, this would be side little b, and this would be side little c. I would then build my table just like normal. So I'd say angle A is equal to, well, we don't know, actually. That's what we want. Angle B is 55 degrees. And angle C is, again, we don't know. Side A was given to us to be 24. Side B is given to us to be 21. Side C, we don't know. But luckily, we have a full row, which tells us we can use law of sines. So I'm just going to go ahead and zoom in there. I'm going to say this implies we're using the law of sines. And of course, you can see it's the unfortunate situation where we are going to use law of sines. We can't find angle, or actually we're going to find angle A. That's what we want to find. But it's going to be possibly the ambiguous case because you're using the law of sines to find an angle. And remember, when using the law of sines to find an angle, you need to check whether the supplement of that angle could have fit. Also, use this picture. This picture is actually this way on purpose. This angle is obtuse, and the sine inverse will never return an obtuse angle. So this tells me this is going to be an ambiguous case. But let's just see. Let's just see if we would have detected it. So I go through my work here. I say, okay, well, I need to find angle A. So the sine of angle A is to side length A, as the sine of angle B, which is 55 degrees, is to side length B, which is 21. Multiply both sides by 24 and then take the sine inverse. You'll get A is equal to sine inverse of 24 sine of 55 degrees divided by 21. You feel pretty good about that. And so you go ahead and go grab yourself a calculator to figure out what the angle is. And here we are at the calculator. I'm going to put angle A is equal to the arc sine of, and we have 24 sine of 55, and that's being divided by 21. 69.4 degrees. So I'll go ahead and come up here and write in approximately 69.4. But the question is there a possibility that the supplement of 69.4 could have fit? So again, down here, I'm just going to ask that question. So there's the question of the day. Could 180 degrees minus 69.4 degrees, in other words, could the supplement, which is 110.6 degrees, have fit? And if you look up here, you had 55 degrees to begin with. If you add another 110 to that, you have 165 degrees. Definitely still have room for an angle C. They're not asking us to solve the triangle. They're just asking us to find what this angle A is. And notice it's obtuse. So, because I know there are two triangles, so I'm going to say yes, then A bar would be 110.6 roughly degrees. Well, that's what this angle is, 110.6, because by virtue of the picture they've handed us, that's what it is. So this angle is 110.6 degrees. And we are done with that problem. So the ambiguity here allowed, along with the picture they gave us, allowed us to find that answer pretty quickly. All right, that's it for this part of computing or using the law of sines to solve triangles. The next video in this series, we're going to step away from the law of sines just momentarily to talk about the area of a triangle, and then we'll hop back in with a final video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Aims for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.